Hi, in this video, we'll be talking about rotation of rigid bodies. Note that in reality, real objects always deform to some extent when forces are applied, while idealized rigid body does not deform, bend, or stretch in any way. On the other hand, when we say rotation or rotational motion, it is simply a motion of any object which is rotating about a fixed axis. Consider a rigid body described by line OP rotating about a fixed axis passing through point O. So as this body rotates, it travels a certain arc length s, which is given by the equation r theta. R stands for the distance between O and P, or its radius, and theta is the angle from its inertial frame of reference. Rearranging this equation in terms of r and s, we'll have this equation. This theta here is also known as the angular displacement or angular position. The angular displacement in rotational motion is measured in radians, but it is also expressed in terms of degrees and revolutions. Take note that for one complete revolution, that is simply equal to 360 degrees, or also equivalent to 2 pi radians. And if we'll have half of the revolution, so you'll have 180 degrees, or that is simply equal to pi radians. So an important conversion here is that if you're converting degrees to radians, all you have to do is to multiply pi and divide by 180 degrees. Take note that the value of your pi is simply 3.14. Or vice versa, if you want to convert radians to degrees, all you have to do is to multiply 180 and divide by pi. When the angular displacement changes over time, this will give rise to angular velocity. So basically, this is simply the change of your angular displacement over the change in time. And its SI unit is in radians per second. Again, once daw mo rotate ang particle o mag-change ang position from its initial, so pasabot kay na siya'y angular velocity. If you'll notice, this is analogous to linear motion. Pare-parehas lang sa linear motion ang rotational. So here, sa straight line nga motion class, is that if I have here a particle nga ang initial position kay x1, and then ang final position, shall we say, kay x2, here. So once mag-change og position over time, naa kay linear velocity. Inga na ang concept sa linear motion. Murag similar pod sa rotational nga motion. Naa kay initial position nga theta 1 sa imong sa imong rigid body. Once mo rotate siya, so meaning to say na siya angular velocity. And also take note that this can be positive, negative, ang imuhang value sa imuhang angular velocity. Kano sa aman. Positive siya whenever ang imuhang rotation is counterclockwise. This is simply a sign convention. Pwede nimo ang imuhang counterclockwise kay negative. And then, ang other nga, ang opposite nga rotation would be positive. But for me, I'd prefer nga counterclockwise nga rotation will be positive, and then ang clockwise nga rotation kay negative. And take note, angular velocity is a vector quantity, so how to determine its direction? So here we will use right-hand rule. Ang pinakauna kay ang rotation will be ang direction sa imuhang fingers. Okay, again, kung i-curl ni mo imong fingers using your right hand sa direction sa rotation, ang thumb will be the direction of your angular velocity. So again, kung 3D siya, this is your x, y, and z. So ang tendency, tara ang rotation, no? Okay, so ang thumb will be the direction of your omega. So for this case, ang imong angular velocity is directed towards positive z-axis. But then if imong baliktad ang rotation, so basically here kani, so ang curl sa imuhang ang fingers ang direksyon sa rotation, ang thumb ang direksyon sa angular velocity. So, since ni oppose man ang direction sa rotation, so opposite pud ang direction sa iyahang thumb. So meaning to say, towards negative z direction ang iyahang omega. Take note nga ang subscript nga z diri kay dili pasabot nga ang particle is moving along z, but rather ang axis of rotation is naa sa z-axis. Okay, so once mag-change ang angular velocity over time, this will give rise to angular acceleration alpha. So ang tendency is that you'll have here delta omega over delta t. So again, analogous gihapon sa inyong linear motion. So this time, if I have here a particle and I have velocity v1 at this point, and then nag-change of velocity at this point, so once mag-change ang velocity, linear velocity over time, it will give rise to linear acceleration. Okay, similar gihapon sa rotational. Ang tawag lang sa iya kay angular acceleration. So once mag-change ang imuhang angular velocity, so meaning to say na pud siya angular acceleration. And its SI unit is in radians per second squared. So kana siya unsay pasabot kung positive or same og direction ang imuhang angular acceleration og ang angular velocity, meaning to say ang rotation kay nagka-kusog. And if it's opposite, well then ang rotation is simply nagka-hinay or slowing down. And if your alpha is simply equal to 0, na duha ka meaning 1, it could either be at rest or no rotation at all sa rigid body. Or it could be rotating pero constant ang rotation. From these four variables such as theta, omega, alpha, and time gives rise the four kinematic equations of the angular or rotational motion. This really looks familiar since this is similar to linear motion, wherein we could therefore observe and see that your theta is the rotational analog for x, y, and z. The omega, or the angular velocity, is the rotational equivalent for v, linear velocity. And the angular acceleration is the rotational equivalent for the acceleration a. Take note that we can relate linear and angular kinematics. So when a rigid body rotates about a fixed axis, this rigid body here, rotate about this fixed axis at point O, every part of body can move in a circular path. If I'll choose this point P, which is part of this rigid body, and iparotate nako, ang path nga i-take ni point P is a circular path. And the length is simply determined by the equation sa arc length, which is simply S is equal to R theta. Again, where R is the radius, gikan sa point O, paingon sa point P, and the theta is the angular displacement ni P. Once if mag-change imuhang displacement or rather the length over time, so napoy change sa imuhang theta. So here, again, once mag-change imuhang length, or shall we say distance over time, so ang tendency, ang R is simply constant, right? Yes, we can factor out that one from the delta. Okay, constant man na siya all throughout. So ang tendency is that kining distance over time is simply your tangential velocity or tangential speed rather. And kaning change of the angular position over time is simply your omega. So therefore, your tangential speed is simply equal to r omega. Note that the direction of your tangential velocity is always tangent to this circular path. So if nadri among point P, ang direction sa tangential velocity is in this direction, v tangential. And if not this point, ang point P, ang direction sa v tangential is not this point, downward, and so on. And also, we can relate acceleration, linear and angular acceleration for this case. Take note that linear acceleration has two components. One is what we call as tangential acceleration, and the other one is radial or centripetal acceleration ang tawag sa iya. When we say tangential acceleration, mag-act siya to change the magnitude of the velocity, the particle's velocity. So ang tendency is that acceleration is simply change of velocity over time na siya, no? So v tangential over time. And we all know that v tangential is simply equal to r omega, right? And this change of the angular velocity over time is simply the alpha. So therefore, ang tangential acceleration is simply equal to r alpha. And take note that it is always tangent to the circular path parallel to your tangential velocity. The other one is what we call as centripetal or radial acceleration. Okay, so ang tendency, ang equation sa radial acceleration is equal to v squared over r. And again, v tangential is equal to r omega. So distributing the squared, makancel out ang isa ka r. So your radial acceleration is equal to omega squared r. And take note that this a radial always points to the axis of rotation. So tendency, this is duha ka acceleration mag-exist. So you'll have a tangential and then the radial acceleration. One way to add these two is simply makita nimo ang linear acceleration. And take note, we can find its magnitude by using Pythagorean theorem. Again, I'd like to emphasize that the A tangential is used to change the magnitude of your particle's velocity, while your radial acceleration is simply associated with a change in the direction of the particle's velocity. Again, magnitude ang isa kay direction. And once your tangential velocity is constant, so mo rotate or uniform circular motion class. So basically, if v tan is constant, tangential acceleration is simply equal to 0. Ang naong sa motion kay uniform circular motion. Isa ra ka acceleration ang ga-exist, and that would be your radial acceleration. Take note also, there is an energy associated in rotational motion. So if you try to consider here a rigid body, which is naisulod nga daghan kay nga mga particles to the ith particle. Shall we say ang particle 1 ay mass 1 with a distance r1 gikan sa axis of rotation, and particle 2 with mass 2 and a distance r2 gikan sa axis of rotation, and so on and so forth. The moment this body rotates, na kinetic energy associated with that one, and that is simply equal to 1/2 mv squared, the kinetic energy sa kada particle. And take note that your tangential speed is simply equal to r omega, right? So, atong i-substitute diri so the kinetic energy would look like this. So here, in order to calculate the total kinetic energy of the whole system aning a body, all you have to do is to, yes, add all the kinetic energy sa individual nga particle. So here, so all I have to do, pwede na ko i-combine all in all since, yes, they are scalar quantities ang kinetic energy. So we'll have this expression nga na diri. So na common variable, that would be your 1/2, and then your omega squared. So we're going to factor out that one. So one tendency is that this miri squared is simply your moment of inertia. So the rotational kinetic energy is simply equal to 1/2 I omega squared, where I is simply your moment of inertia. This I here measures the difficulty in starting or stopping the rotation. Again, this is the rotational equivalent of mass in linear motion. So sa laktod nga pagkastorya, ang mass is simply amount of inertia sa usa ka object. Inertia means to say it resists motion of an object. If atras siya, mo-resist siya nga mo-move. And if nga move siya, mo-resist siya mo stop. So similar for this one, ang moment of inertia nga I. It's simply kung address ang usa ka object, mo siya nga mo rotate. And if it's rotate na daan, it's simply mo siya nga mo stop from rotating. Okay? Each of the particles have different moment of inertia depende kung asa ang axis of rotation. For example, kung nakay cylinder, solid cylinder and hollow cylinder, different nga moment of inertia. Sphere and hollow sphere. If you have a rod, depende kung asa ang axis of rotation, mag-differ gi hapon. So these are the list of moment of inertia of different solids. And the general equation in calculating the moment of inertia is simply this one. Okay, so the integral of dr squared dm stands for the infinitesimal mass. It depends if your mass is distributed in a line, in a surface, or a volume. And one way to calculate for the moment of inertia is by using parallel axis theorem. So here is that it gives relationship between the moment of inertia about the center of mass and the moment of inertia at any point, okay, which is simply parallel to each other. And take note, as a wrap up, there is a relationship between your linear or rotational motion. One thing for sure is that one, sa linear motion, kung nakay position x, y, and z, of course, inigabot og rotational motion, that is simply your angular displacement. And if mag-change ni siya over time, this gives rise to, yes, velocity. Okay, mag-change ang position over time gives rise to velocity. At the same time, ang rotational analog or equivalent niya is omega. So once mag-change pod ang imuhang um, displacement over time. Once mag-change ang velocity over time gives rise to acceleration. Here, once mag-change ning velocity, angular velocity gives rise to angular acceleration. The other one is the rotational, if you'll have mass, the rotational analog for that one is simply your moment of inertia. If you'll have a kinetic energy sa linear as 1/2 mv squared, well, the rotational kinetic energy is simply equal to, the rotational analog for m is I, so you'll have 1/2 I, and the rotational analog for v is simply omega, so you'll have omega squared. Okay, for example, one thing for sure in the next videos, for example, if you'll have momentum, which is simply equal to mass times velocity, well, inigabot sa rotational, this is simply what we call as angular momentum, which is simply equal to, the rotational analog for mass is I, and the rotational analog for V is omega. And even for force, okay? So if you'll have force is equal to ma, okay, the rotational analog for force is simply your torque, which will be discussed in the next videos. And m, the rotational analog for mass, is the moment of inertia, and the rotational analog for acceleration is angular acceleration, and so on. So that would be all. Thank you so much for watching.